So one thing I find that my students struggle with is this notion of completing the square. And there are a couple different versions of it. It can vary in complexity. And so I just want to start with motivating and explaining what do we mean by completing the square. When we're looking at expressions of the form, say, x squared plus bx, where b is any real number, and we want to add some sort of term, a constant term, such that what we get factors perfectly as a perfect square. And we want the thing on the right to have the form, let's say, x plus a squared. And so we want to figure out two things. We want to figure out, one, what a is, and then two, what do we have to add here so that things work out this way. And so we're going to work backwards. This is x plus a times x plus a, quantity squared. If we, oops, not squared, excuse me, just x plus a times x plus a, that's what exponentiation means. And if we expand this, we get x squared plus ax plus ax plus a squared, which is x squared plus 2ax plus a squared. So let's do a little side calculation. If these two expressions, the one on the left-hand side of the equal sign here and the expression on the right-hand side of the equal sign are going to be equal, then certainly the terms need to match up, so the powers need to match up. X squared needs to be equal to x squared, which it is, and the coefficients here are both 1. But then we need the linear terms to match up, so the bx term must be equal to this 2ax term. Otherwise, these expressions aren't equal. And then this constant term has got to be equal to this constant term. So we're going to use the fact that the linear terms have to be the same to solve for a in terms of b, because we'd be given b in a problem. So we need bx to equal 2ax. x's here cancel, and we can solve for a as b divided by 2. So now we're going to substitute this expression for a back into here into the right-hand side. So we have x squared plus 2 times b over 2, x plus b over 2 squared. So we've answered one of our questions, right? Our first question was, what does a have to be? And a has got to be b over 2. Simplifying, we see that we indeed have x squared plus bx plus b over 2 squared. And now we've answered our second question, which was, what do we need to add to x squared plus bx to be able to factor that expression perfectly? And the answer is, we take the coefficient of the linear term, in this case b, we divide it by 2, and we square it. Okay, so let's see, we're going to see two different examples, okay, of how we can use this idea of completing the square. And I'm going to go ahead and copy that down so that we can see it. So now we're back. And let's see an example or a couple of different examples of where we might use this technique for completing the square. So our first example is a really common one. We want to determine the center and radius of the circle given by x squared minus 6x plus y squared minus 8y equals 0. So we're actually going to complete the square twice here. We're going to complete the square once for the x terms and again for the y variable. So we have x squared minus 6x. We want to add something. And we have y squared minus 8y. Again, we want to add something. Now, it's important that we realize we can't just add things to an equation willy-nilly. If we add to one side, we then have to also add those things to the other side. So now, according to our work from above, what do we need to add? Well, we need to take 1/2 of this linear term and square it. So 1/2 of -6 is -3, and -3 squared is +9. And then we're also going to do the same thing here. We're going to say 1/2 of -8 is -4, and -4 squared is +16. Of course, we can't just add 9 and 16 to one side without adding both 9 and 16 to the other side of the equation. We can now factor these three terms as a perfect square and factor these three terms as a perfect square. So we'll have x and y. Now the question is, what goes here? Well, what goes here is exactly b over 2, right? So you take half of this linear term, and that's always what's going to end up here. So 1/2 of -6 is -3, and 1/2 of -8 is -4. And we can always check our work, right, by just foiling this out and going backwards. So x minus 3 quantity squared, the outside and inside terms add up to -6x, and then -3 times -3 is, of course, +9. Here, -4y and -4y add up to -8, and -4 squared is 16. And on the right-hand side, we have 25. So now this is the general form for the equation of a circle, and we can answer our question that the center of the circle is located at 3, 4, and the radius of the circle, which is given by the right-hand side, this is r squared, so r is the square root of 25. So r is equal to 5. Now, our second example is going to be slightly different. because we're not always given an equation, sometimes, well, it's still an equation, but we're given a function instead. So example 2, the goal is going to be slightly different. So our next example, what we want to do is find the vertex of the parabola axis of symmetry and x-intercepts if there are any. There might not be. And we're going to do this for the function f of x is equal to x squared plus 10x minus 15. So again, we want to complete the square. But this time, it's not as if we have this equal to something else and we can just add something to both sides. So instead of adding to both sides, we will add the term that completes the square. We will then subtract that same thing. When we add and subtract the same thing, it's as if we're adding 0. So these two terms are like adding nothing. And so if we remember our additive identity, x plus 0 is always still x, we're in good shape. So according to our work from above, to complete the square, we're going to take 1/2 of the linear term and square it. That's what we're going to add and subtract. So 1/2 of 10 is 5, and 5 squared is 25. So we're going to add 25 and subtract 25. These three terms now make a perfect square. So we have x plus 5 quantity squared. And now, to finish this off, we group our constant terms here together. And so minus 25 minus 15 is going to give us, what, a negative 40? And now we can answer our questions. So where is the vertex of this parabola? The vertex is located at -5, -40. It opens up. The axis of symmetry, or the equation of symmetry, is x equals -5. And then finally, if we want to know if there are intercepts, we can say we want to solve x plus 5 squared minus 40 equals 0 to find out when where the x-intercepts occur. So we would have x plus 5 squared equals 40. Taking the square roots of both sides, we then obtain x plus 5 is plus or minus the square root of 40. So x would be negative 5 plus or minus the square root of 40. So finally, we can graph. Let's see here. So we'll make this negative 5, say minus 10, minus 20, minus 30, minus 40. There's our vertex. Here is the axis of symmetry. And this parabola opens up, like so. And these two roots correspond to these solutions. So this completes our first lesson on completing the square.